guys, has heard of function or a function? Yeah, what does it mean? No, I don't know. No, not that kind. Okay, I should specify. A mathematical function. Say it again.
Ariana, it's like a equation or a problem that you use to find the answer.
Okay, it can be. It can be. Anybody else? It's a type of relation. Remember, we've been talking about relations, right? Domains and range, x's and y's. So input, output, independent, dependent, right? A function is a special kind of relation. A function is a relation. How can I word this? A relation that every input let me word this a little differently. That I'm sorry, I know.
I know the bridge is from.
That there is one and only one output. Output is what? Which variable? Output, y. For each input, which is x. Okay? So that's kind of wordy and confusing. That's why I was sitting here thinking, how can I word it for you exactly right? But I think it's a little easier if we see it, if we look at some relations in the form of a table, in the form of a graph, and in the form of some points, and determine whether or not they are functions. So, for example, maybe I have, and remember our synonyms here, okay? Output, y, what's another word? Dependent, what's another word? Range. Somebody said it, range. Give me the synonyms for input. Independent, dependent, and domain. Okay? All right, let me give you a table. Let me give you a mapping, and I want you to determine, let's determine yes or no, it's a function. -2, 0, 3, 4. -3, 6, 9. This is going to be my domain. This will be my range. So in other words, my x and then my y, right? Let's go. Does every input have exactly one output?
No. Because their output is the same.
Okay, let's look.
Yes, it does.
How many outputs does -2 have?
1.
How many outputs does 0 have?
1.
How many outputs does 3 have?
1.
How many outputs does 4 have?
1.
They all have exactly one output. Do you see that? Do you see that? So yes, this is a function because every output or every input has one output. Okay. Let me show you another one. I'll give you a second to copy that now. Show you another one. I'm going to do these as points. The question is this a function? Yes or no? Does every input have only one output? Why? What is the output for 1? Is it? And negative 4. Do you see that? Good job, George. There's 2 outputs. It has 2 outputs, right? This one value right here, if my input is 1, my output is 4 or negative 4. That means it is not a function. Does that make sense to you? Okay. Look back at the other one. Okay. What is the output for negative 2? Negative 3. What's the output for 0? What's the output for 3? What's the output for 4? There's not any input that has 2 different outputs, right? No x has 2 different y values, but here I've got the same x with 2 different y values. So it's not a function. Okay? So what you're looking for when you look at these, when you're looking as points or a table or a mapping, what you're looking look for the same x with different y's means not a function. The same x with different y values means it's not a function. Does that make sense? Does that make a little better sense? Yes, Miss McGee? No, Miss McGee. Let me give you another one. Okay. Function, yes or no? No. Why? Because the input value 2 could be 1 or negative 2, and the input 3 could have an output of negative 2 or 1. Okay? The same x's have different y's. That cannot happen. Okay? How about this one? Function, yes or no? Does every input have only one output? Yes. Does it matter that 2 of my outputs are the same? No, that doesn't matter. That does not impact it being a function. Y'all with me? So yes, this is, yeah. If I give you a list of points, yes ma'am. It's the input that you're looking at, because you can't have the same x value with different y values. All right, shh. I feel like maybe we're okay, maybe we're not. We good? All right, let's talk about some types of functions. 2 types of functions we're going to talk about. The first one is what we call discrete function. Discrete. Not like you own discrete, like discrete. All right, so a discrete function is made up of points. It's not connected. It's not smooth. So maybe, and here we're really talking graphically when we talk about these types of functions. So everything we've done so far with our relations have been discrete because they've just been sets of points, right? Maybe I have something like this. That is a discrete function. Notice how they're not connected. They're just random points in there, right? That is what it means to be discrete. The other type, I'll give you. The other type of function we're going to talk about, you need me to go back? The other type of function we're going to talk about is what we call continuous. So continuous is, it is connected. Think about, boys, if you could draw the graph without lifting your pencil. Smooth, connected. Think about a line. Maybe something like this. Or maybe something like this. Those are all continuous functions. I don't have to lift my pencil up when I draw them. I'll put that. Don't lift your pencil. Let me do an example, pulling together what we've done so far, and then we'll talk about the graphs. You have 3 lunch periods at school. Let's just say you have 3 lunch periods at school. We used to have 2.
It's like, it's not everybody goes to 2.
Yeah, like you go to one of the 3, right? In first lunch, there are 352 students who attend. This is a big school. In second lunch, there are 304 students that attend. And in third lunch, there are 391 students that attend. What if I asked you to make a table showing the number of students for each of the 3 lunches? How would you make a table for that? I pretty much got it in table form, right? If I just kind of separate it like this, this is my lunch and my students. That's exactly right. So what's the domain here?
Lunch.
The lunch, right? 1, 2, or 3. What's the range?
Students.
What's the output? Students. What's the independent variable? Lunch. That's right. Switching it up. Good job. Good job. Way to stay with me. Is this a function? Yes or no? Why? Every single, good job, George. Every single x has one and only one y that goes with it. I think I might have wrote that backwards in your very first sentence. I think I might have put output where input should be. I think it should be backwards. It's right? Okay. All right. So, yes, this is a function. Is this a discrete function or a continuous function? Why?
It's dies.
Exactly. It's good job, y'all. It's just points, right? It's 3 different points. There's no line that connects them. Everybody okay on that? All right, let me talk about the graphs for just a second. We're almost there. You know, I don't like to stand up here and talk too terribly long. How can we tell, guys, y'all stay with me. How can we look at a graph and tell if it's a function? So we got to think about this for just a minute. They're doing the recycling. They have to take the trash can down the stairs. So let's think about this for just a second. I'm going to put 2 graphs up here. One of these is a function and one of them is not.
Okay, one on the left is function. No, the one on the left is, yeah. It's curved. It doesn't stop.
All right, this first one. Function. Well, we know it's continuous because it doesn't stop. But the question is it a function? So remember what makes it a function? one output for every input, right? Every input only has one output. Is the first one a function, yes or no? So I hear yes, it's a function. Why? All right, this is my x and this is my y, right? Every single time I go to an x, anywhere on here, there's only one y that goes with it. Do you agree? Okay? There's not repeating any x that you have doesn't have two different outputs. But look at the second graph. If I go to this input, so this x value, how many outputs does it have? Two, here or here. So it's not a function. Do you see why? Okay, so we use a little easy test so you don't have to think about that every time. We call it the vertical, all right, vertical line test. All right, and here's what that means. If you look at it, it really makes sense. If you can take a vertical line, and I wish I had like a yardstick or something to show you. I'll use my pen. On your paper, you can use your pencil. If you take that vertical line and you come across the graph, if it only touches one time everywhere, it passes. It is a function. If you can put a line somewhere, like look here, and it touches the graph twice, that means it has two outputs. That means it's not a function.
So it touched the line twice.
If you can take a vertical line, okay, if you can take a vertical line, and I'm letting my pen be a vertical line, pretend like that's a vertical line, right? If I could take it and anywhere I put it, it would ever cross more than one time.
Oh,
It fails.
It fails.
So it's not a function.
Golly.
Okay? But if you look at this first one, there's nowhere that I can put a line where it would hit more than once. It's always only going to hit one time. So it is a function. It's just an easy way of looking at the inputs and outputs. Okay, that's called the vertical line test. Does that make sense to you? Let me show you two more. You tell me function, yes or no, and why. Did y'all say hold on? Function, yes or no?
Yes.
Why? You can't put, it passes the vertical line test. So you can literally say it passes, guys, it passes the vertical line test. How about this one?
Wait. Yes.
This is actually easing out, so yes, it passes the vertical line test. It is a function. How about why? If this were my line, that one input has three different outputs. It fails, it's not a function. Okay, it's failing. Tanner, put that up, please. All right, y'all got it? Everybody okay on that? One more thing I need to tell you, and I'm about done. When we have the equation of a function, okay, we've talked about as a table, we've talked about as ordered pairs, we've used mapping, we've talked about what the graph looks like. If we have an equation that is a function, okay, so maybe it's y equals 2x plus 3. We all agree y equals 2x plus 3 is a function? Because it's a line, right? Any kind of line we have that looks like this is going to be a function. No matter the slope or where it is or anything. As long as it's not a vertical line, it's a function. Okay? So what we can do is we can replace the y. Do y'all remember this?
No.
Okay. We can replace the y with this. And we read this as f of x. And it literally means function of x. So if you ever see it, It's the same thing as y equals. It's just saying, hey, this is y equals, but when you graph it, understand this is a function. Every input has one output. Yeah.
Okay, so I understand that, but I didn't know that it was like the function like next to the x. Like, does that mean function times x?
No, it's just notation. It just means that it's a function of x. It's the same thing as y. It's just letting you know that this just tells you it's a function and the input is x. That's your input variable.
My teacher didn't explain that. She just put it up on the board one day. And I had no idea what
I'm sorry. Yeah, it does, and that's a common misconception. It doesn't mean to multiply. It's just telling you, hey, what's coming is a function and your input is x. Okay? All right, guys, I know I'm losing you. I'm starting to get a little bit of chatter. Let me just tell you this. It does not have to be a linear function, meaning a line. It can be what we call a non-linear function. So maybe, and you won't be graphing these just yet, but you need to be able to, it doesn't have to be f either. We can use any variable. I could say h of x. This notation indicates function, okay? It's a function with input what? What's the input? X, because that's what's in parentheses, right? And we say h of x. We can call them different things to give them different names so that we can determine between them. So maybe I have an f of x, a g of x, and an h of x, okay? So that I can determine, kind of like y'all all have different names, we can give our functions different names so we know what we're talking about.
Like,
Yeah.
it's like, say, you know, in the parentheses, it's like input, in parentheses, input.
There you go.
No?
Yeah. All right. The function is h. What is the input? X. What if I asked you, what is h of 1? What does that mean? Whatever this is, remember, is my input. So it means my input now is 1. So I replace every x with 1.
Yeah.
Does that make sense to you guys? Does it make dollars? All right, let me just simplify this and I'll give you your homework. Negative 16, remember, move left to right. Negative 16 and 68 would be 52. And another 2 would be 54. Supposed